So this video is going to be focusing on decimals, and I will start by talking about what they are and how to read them. So decimal refers to the entire system that we use to do math, the basic system of 10 digits or multiplying by factors of 10. So for example, when you look at a number, we even call those houses in terms of it being 10 times bigger or smaller than the previous house. Like this is the house of tens, and you could have the house of hundreds and thousands and so forth. This is the house of one. But we call the houses smaller than the house of one the decimal points, right? Or the decimal houses. Now, more specifically, they're all part of the decimal system. But the decimal point separates wholes from parts of a whole. So a tenth is what goes on the first house, then hundredths, then thousandths, and so forth, just putting the THS at the end. That's what a decimal is. It's just another way of representing smaller fractions of a whole number that's not a fraction. Now, how do we operate using decimals? So let's start with adding. When you're going to add decimals, it's very important that you line up the decimal points. So for example, if I'm trying to add 0.32, 12.965, and 1.1, all of which have different amounts of decimals, you have to make sure that all the tenths line up and all the hundredths line up and so forth. Pad the missing decimals with extra zeros. That's basically not adding anything to it. And then vertically add like you normally would in a vertical operation problem, remembering to carry over anything that goes over 10. So in the first example here, 5 for the first column, but the second column is 2 plus 6 makes 8. On the third column, you have 9 plus 1, which is 10, plus 3, 13. So 1 is going to carry over when you're trying to do the next column. So 1 plus 2 plus 1 is 4. And last but not least, 1. Then the decimal point will be in the final answer exactly lined up if you actually did this right. So all you have to do to add decimals is line them up. And that's how you put decimals together. Here's another example that we can look at that. 51, which is actually a whole number, plus 14.02 plus 2.1. You line them all up, all the ones in the houses of ones, all the tenths in the houses of tenths. And since the 51 didn't have decimal, you just add them, 0, 0. And then vertically add like you normally would. So this is how you would go about adding decimals. How about if you were trying to find the difference between two decimals? Okay, so how would you do that? Kind of like the same thing. You would have to line them up first. Okay, now we're going to talk about the fact that the first thing you need to figure out here is what you need to do, because you could need to add them to each other. But right now I'm just talking about how to find the difference between the two decimal points. Okay, this would have to be slash and slash, and then you have to realize that you are actually trying to add opposites, and therefore opposite signs, you must find the difference. So how do you find the difference between the decimal? So first thing I would tell you is always put the larger number on top, okay? Then make sure the decimals are lined up again, all the tenths in the same top of each other, and be very careful so that they're vertically aligned, all the hundredths aligned to each other, and then you do the same thing you would any normal problem, pretending the decimal's not there, except in the final answer, you got to make sure to include that decimal point, just where it is vertically. So over here, we go from 2 to 7 is 5, 1 to 9 is 1, and then 2 to get to 6 is 6. So I'm trying to find the difference of each number. Do remember that whole borrowing thing. If you have to find a difference between a number that is smaller on top, then you have to borrow from the previous number. We will do examples like that when we do the workshop at the end. Or maybe I should just do one right now so that we can see how that's done. Let's do 5.1 minus 3.8. So we're finding the difference between these two numbers, right? Now remember how that would work. They're all lined up, so there's going to be a decimal point here in the answer as well. Now 8 isn't smaller than 1, so you cannot really find a difference. So you have to borrow from the 5 and turn it into a 4. And then turn this into an 11. Now, 3 goes to 11 if you add to 8. right? So it's a difference of 3. And then the difference between a 3 and a 4, remember it became a 4 because you borrowed, is a 1. And now you have your final answer, 1.3. So that's the borrowing thing that I was talking about. But the point is to find a difference, make sure the decimals are lined up. So in general, to put decimals together or to find a difference between them, you have to just make sure to line them up and pad extra if you need to, carry over when you're adding, borrow when you're subtracting if you need to, right? You carry over when it goes over 10 when you're adding, you borrow and subtracting when it's a smaller number on top. And the only other thing is that when you're subtracting, you got to make sure that the bigger number goes on top when you're trying to find the difference. Now, the next thing that you really have to think about is that when it comes to 7th grade math and you're trying to add or subtract decimals together, before you add or find a difference, you have to realize which one do you have to do. So here's a few examples. Let's see if you're doing minus 1.2 minus 3, right? Or let's say you're doing negative 1.2 plus 3. Let's say you're doing negative 1.2 minus 3. Let's just look at those 3 as examples. So in this first one here, you have a subtraction sign. So the first thing you need to do before, so this is the 7th grade bit, right? So before you need to do anything, you have to make sure to slash here to change the operation and then change the sign of the next number. But then it becomes evident that you're actually trying to put together 2 negatives. So you're not subtracting at all. What you're actually going to do is put together. So you're going to put 1.2 plus that 3, pad the difference, and put those numbers together, and you would get 4.2. Now, because they're both negative, you got to remember that the answer is going to be negative at the end. So this would actually be negative 4.2 for your final answer. So the new feature of a 7th grade curriculum is that before you decide if you're adding it together or if you find a difference, you have to think of the rules of adding and subtracting. So let's look at another example of this. We have here negative 1.2 plus 3. Now, in this case, we're trying to add numbers that have different signs. What's the adding rule say? Well, you're actually supposed to find a difference. So even though there's an adding sign in between them, what you actually have to do with those numbers is find the difference. So you're going to have to do 3, larger number on top, pad it so it matches it, and then 1.2, and find a difference between them. Borrow from the 3 because 2 is smaller than 1, and then 2 to go to 10 is 8, and then 1 to go to 2 is 1, so you get 1.8. So the answer is 1.8, but then you have to think about the sign of your answer. You got to remember that when you're doing this to keep the sign of the biggest, so it's going to be positive 1.8. But notice that even though it was a positive sign between the numbers, I ended up subtracting them because the goal was finding the difference between them, as the rules of adding say. Lastly, if you're trying to do this one slash, so it looks like I'm doing negative 1.2 plus 3, which is the same thing I just did. So that is the same thing as 1.8. I have to find a difference between them. So the basic rule for dealing with adding and subtracting decimals is that before you actually add or subtract, you have to think about the rules of operation, right? If you're adding them, if there are different signs, you can actually find a difference between them, which means you're going to put the big one on top, pad if you need to, and actually subtract the numbers. Then when you get that answer, you think about your sign. The sign of the biggest wins, right? So like you saw in the example, it was 1.8. By the way, let's do one last one here. What if you had it the other way around? What if this was 1.2 minus 3? We already did that, but now with the negative 1.2. So let's do 1.2 minus 3. So when you actually slash and slash, see, the signs are different. So I actually have to find a difference again. So again, it's going to be 3 on top minus 1.2, which is 1.8. because the difference between them is 1.8, but I have to keep the sign of the biggest. And in this case, the biggest is 3, and its sign is negative, so my answer is going to be negative 1.8. So first, you actually think about the rules of adding and subtracting, slash if you need to when you're subtracting, right? Slash the sign, and then change the sign of the number that comes after. Then think about the rules of adding. If the signs are different when you're trying to add, you're actually going to end up subtracting to find a difference, and then keep the sign of the biggest on your final answer. If the signs are the same, like you saw in the first example, you actually have to put them together, add the numbers. But then the sign is the sign of the problem that was there. So if it was negative, it becomes negative. If it was positive, it becomes positive. So one more time, what do we do? First, if it's subtraction, slash the operation to change the sign, and then change the sign of the number after. Then once you're back to adding, or if you started with adding in the first place, if the signs are different, you're actually going to subtract the decimals, find a difference, put the top bigger decimal on top, add anything that you need to, line up the decimals, subtract them, and then think about the sign of your answer. The sign of the biggest has to stick, right? If the signs were the same when you were adding, then you were actually going to put them together. Even if they were both negative, if they were both positive, put them together and keep the sign. So it's the same thing we did with the integers, except that you have to make sure you line up the decimals before you either find a difference or put it together, and then think about the sign of the answer. So that can be a little bit confusing. So we're going to do more practice on this on the workshop at the end of the last video of the series. So make sure that if this is still confusing to you, that you look at that practice before you think you're ready. How about if we're trying to multiply or divide decimals? So let's look at some of those examples. Multiplying decimals is a little easier because you do not need to worry about lining them up. Just list the decimals and then do normal multiplication like you would with any number, except at the end, you have to count the decimals, and the total number of decimal points in your answer has to be the same as the total number of decimals on each of the parts combined. So this example here, 2.34 has 2 decimals, and 1.2 has 1 decimal. So the total number of decimals in the problem was 3, and therefore my answer has to have 3 decimals as well. Don't line them up and just multiply, right? So let's see. 2 times 4 is 8. 2 times 3 is 6. Now, they're not actually showing you all the steps, so I'm going to show you that over here on the side. 2 times 3, 4, times 1.2. By the way, I always put the number that has last digits in the bottom because it's last work that way, right? So 2 times 4 is 8. This is how I do it. There are other ways to multiply, but this is how I learned it. Then I do 2 times 3, which is 6. Some people like to skip a line and then write 60 because you're really doing 2 times 30. And that works too, if you want to think of it that way. But then you need extra lines to do it, and I don't like it to do it that way. Then 2 times 4 is 2 times 2, is 4. Now again, you can do the 2 times 200 on the next line and do 400, but this works too. All right, now I'm going to work under the 1, which means I have to start with a 0 because I'm really doing 10 times 1, right? I'm not doing 1 times 4, I'm doing 10 times 4. So you got to start with a 0 and then work underneath the 1. That's the way I like to do this. There's another way that's just like thinking about doing 10 times 4 and writing that under the line. But I prefer doing it this way. So 1 times 4 is 4. And then 1 times 3 is 3. 1 times 2 is 2. Now that you have all of them solved like that, the next step is to just add it all up together. Now, 0 times 8 is, plus 8 is 8. 4 plus 6 is 10. 1 carries over to the 4. Now this becomes a 5 now, right? Or I just put 1 plus 4, which is 5, plus 3, which is 8. It's not 14. It's a 1 that carried over to the top there. So it's more like this. So you got a 4, and you carry over a 1. So it's 1 plus 4, which is 5, plus 3, which is 8. And then 2. And then you get that answer that they got. But because the question has 3 digits total, my answer has to have 3 digits total. So it's going to be 2.808. Now, the only difference for 7th grade, this is already something that you should have learned before 7th grade, is that you have to think about the signs when you're done with all of this. Now, in this example, you have 2 positive numbers, so of course the answer is going to be positive. But if it was negative 2.34, then this would be negative at the end because it's only one negative, right? Or if this was like this and you had negative 1.2, then again, your answer would be negative because there's only one negative. But if they were both negative, then negative times negative makes positive, and so your final answer would be positive. And that's pretty much how you do it. Just in case you've learned the other method of doing multiplication, I'm going to show that too. You can skip by this one if you want to, but I'm just going to show it for the people that are going to get confused because they don't really know how to do it the way I did. You can do 2 times 4, which is 8, then 2 times 30 on the next line, which is 60, 2 times 200 on the next line, which is 400. Now notice that if you put those lines together, you get 468. That's all I'm doing, and I'm doing it all at once in one line, right? But that's essentially what you would get if you did this, right? Then you go to the next line. You do 10 times 4, which is 40. And notice that I did the same thing over here by starting with a 0. So it starts with a 40. And then you do 10 times 30, which is 300. And then you do 10 times 200, which is 2,000. But you got to be careful to make sure that all the numbers line up vertically carefully so you don't make a mistake. And then you just add up vertically. All in the first line you have 8, but that's the same thing as the first one because all of these were just zeros. And then the second line you get 6 plus 4, which is the same thing we did before, right? So, and then 1 carries over. 1 plus 4 plus 3 is again 8. And then just the 2 on the end. And then you have to think about the decimals. We got 1, 2 decimals here, and then 1 decimals here. That's 3 decimals total. So it has to have 1, 2, 3 decimals in the answer. So it's going to be 2.808. So that's, you can see why I like to do the left way better because it feels easier to me to have to do less steps. And there are even other faster ways of doing this, which I could teach you if you're interested, but I'm not going to spend time in the video showing that. So that's multiplying. Basically, you do it like you always did. There's nothing new about that. This is a review. The only difference is the sign rules. But again, I am taking the time to review this for the people that don't necessarily remember how to do it. The last skill involving decimals is dividing. And nobody loves long division, right? That's really rare to find a person that gets excited about doing it. And luckily for you, we're not going to do that much of this in 7th grade, but it's still a skill that's important to learn. And how do you do that with decimals? But if you don't have a calculator, how would you go about doing it? Well, the first step is to turn the divisor into a whole number by moving the decimal point to the right. Now, in this case, it's a 1.4, so you have to move it once to turn into a 14. And since you did it once, you also do the same for the dividend. You move it just as many spaces as you moved the divisor. So since I moved it once, I'm going to move it once over here too, and it becomes 36.4. That's like saying that doing 3.64 divided by 1.4 is the same thing as doing 36.4 divided by 14. And that's true. Both of these numbers have been multiplied by 10, which is really what you're doing when you move decimals to the right. Remember, over here, you're making it 10 times bigger when you go to the left. So moving it to the right, you have to multiply by 10 to change the number, right? And if you're moving to the left, you actually divide by 10 to actually do it that way because that's how they compare to each other. So if it's 10 times bigger to the left, you have to multiply times 10 to go right because you're trying to reverse that, right? And that's what's happening here. And it actually works. But either way, the actual technique is making sure you move just the same, but you got to start by turning the divisor into a whole number. And remember, divisor is the term that you're dividing by, and dividend is the term that's getting divided, right? All right, by the way, if this was something like 0.5, you'd have to do it once to go to the right. If it was like 0.54, you'd have to do it twice so that it's 54. If it was like something like 1.32, you'd have to move it twice to go to the right, right? You got to make it into a whole number. And then you make the dividend just as many movements to the right. By the way, if the dividend was like a 3 and it didn't have any decimals afterwards, then you have to turn it into a 30. You have to add a 0, right? Or if the dividend was like 3.2 and you were moving it 2 decimals to the right, so it would be the first decimal would turn into a 32, and the second time you moved it, it would turn into a 320. So if you run out of decimals to move, you just add zeros. It's kind of how that works. Because basically what you're doing, like I just said, is multiplying times 10. Then you are actually divide like you normally would, pretending that the decimals don't exist, pretending they're not there, right? So 2 times 14 gives you 28. If you try 3, it would be 42 or 52, I think. And so 42, yeah, and that would be too big. It would go over 36. So that wouldn't work. And so 2 is what we go with. And then 36 minus 28 gives you 8. You drop down to 4. And then you do 6 times 14, which is 84. If you tried 7, it would be too much. If you tried 5, it would be too little. 7 is exactly perfect. There's no remainder. And so your answer is going to be 26. Now, notice that you're not really doing 364 divided by 14. You're doing 36.4. And so you correct for that by lining up your numbers and making sure that the decimals of your quotient, which remember is your answer when you actually do the division, line up with that of the dividend. And you have your final answer. By the way, there's always possible to check if you got this right. All you have to do is multiply these two numbers together to see if it comes back to the other number, right? So if you do 14 times 2.6, like this, 2.6 times 14, it should give you back the 36.4. So if you reverse the process. Yeah, but no one loves this. But this is how you would go about doing it, okay? And the last thing I would like to add is that don't forget that if you're dividing a smaller number by a bigger number, like this, 0.5 divided by 2, then when you do all of this, you're going to have to start with a 0 on your quotient because the numbers is smaller in order to move the decimals on the actual divisor to a number that's bigger. So it will look something like this. So again, because this number is smaller than that number, I start with a 0, and then when I do that, I can move the decimal 1 over and turn this into a 5. And now that it's a 5, I can actually operate because this would just be 2 times 2 gives you 4. 5 minus 4 equals 1. Now I can add a 0 to keep going. And then 5 times 2 is 10. And that zeroes out. So my answer is going to be 0.25, right? And of course, if this is even smaller number, like for example, if you were doing 0.05 divided by 2, and this is the same kind of process that you would do with whole numbers when you're dividing by a smaller number. It would look something like this. You put the divisor out here, you put your dividend here. All right, so you start with a 0 to make the number bigger, and that would turn into a 0.5, but that would still not be bigger than 2. So then you have to put another 0 after the decimal, right? And now it's a 5. And so you moved it twice the decimal to the right by adding zeros here on the quotient. And then now you can operate normally. And if you did, you would still get 0.025 as your answer. So just showing you that one more kink there. But again, there are other videos about this on the internet. There's practice you can do in Khan Academy, MobiMax, but it's not going to be a skill that's going to be tested too much of you having to do division by hand in long division in 7th grade. So lucky you, but I still wanted to show you how to do that. So in the next video, we're going to review some basic terminology that you should know before tackling 7th grade and rational number arithmetic, and hopefully you find that helpful.